Okay, so let's just talk this through quickly. So we want to extend from our knowledge of whole powers, positive powers to negative powers. So you've been given a list like this to work out so you can spot the patterns, right? So a criterion B type situation. So we put in what we know first. So I know that 2 to the power of 1 is 2. 2 to the power of 2 is 4. 8, 16, 32. Then we kind of look at what goes on underneath. Now you could have a guess. Some people did. Some people put 2 to the power of 0 as 0. Okay? Some people put 2 to the power of negative 1 as negative 2. It makes sense. It's, you know, it's an assumption that you've made, but you've made that a bit more like a guess rather than with any mathematical approach to it. But that's not a problem, right? Once you've had your guess, you've got to think about, well, can I come up with some reasoning behind that? So the way we need to look at it is, what does it mean to go up a power? And the people that I spoke to, we've realised that, well, as you go up a power, you multiply by whatever the base is. In this case, it's 2. So 2 to the power of 3 multiplied by 2 is equal to 2 to the power of 4. So if I go up the list, I multiply by 2 every time. But I actually want to go down the list. So to go down the list, I do the opposite. So I have to divide it by 2. That now enables me to go further down. So divide 2 by 2, I get the answer 1, not 0. Now that leads us to the conclusion that actually every single number to the power of 0 must be 1. Why?
You're dividing the base by the base.
Yeah. Anything to the power of 1 is itself. And then to go to that to the power of 0, you've got to divide it by itself. All right? So that leads us to the conclusion that we already know about, that anything to the power of 0 is 1. We keep going. If you use decimals, you'll find it hard to see. If we use fractions, it's easy. 1 divided by 2 is 1 divided by 2, or a half. A half divided by 2 is a quarter. A quarter divided by 2 is an eighth.
And then I think a 16th.
And 1/16. So we then look at it and we can make our conclusion that, let's say I have 3 to the power of negative 5. I could write that as 1 over, and without having to work out what 3 to the power of 5 is, I could just write, but that's working it out already. I actually just going to write 3 to the power of 5. Because look, 1/8 is 1 over 2 cubed. 1/4 is 1 over 2 squared. So it looks like we take the negative and that gives us the 1 over. The negative does not make it a negative, it gives us a division. All right, Steph.
Everything to the power of 0 except 0 is 1, and 0 to the power of 0 can't work. That's because you can't divide by 0, so it's
Yeah.
0 divided by 0.
Okay. Is 0 divided by 0 not 1?
No, it's the way
It's
there.
because you can't divide by 0 because you don't have multiple numbers.
Cool. Nice that you think that. Desmond, I don't know what you're doing, but you're distracting everyone, and now you're on my video as being a distraction to everyone. Okay. So that leads us to our conclusion about negative powers. So let me just ask you then, just quickly, what is 4 to the power of negative 4?
It would be 1 over 64.
Or just 1 over 4 to the power of 4 first, which would be 1 over 64. Sure?
Yeah. Oh, no. It's 16 times 16.
Yeah.
So it would be...
Was it?
256.
256, that sounds better.
Yeah.
Okay. Right, let me ask you whether we can extend our knowledge, well, apply our knowledge to something that we've already done. What if I said to you, simplify 3 to the power of 7 multiplied by 3 to the power of negative 2? Have a think.
Not undefined.
Who, ladies, would like to give me an answer for 3 to the power of 7 and I just want it simplified? That's it? Jelaine has pointed you out, so get revenge next time.
Is it 3 to the power of 6?
Not quite. 3 to the power of 5, because you add the two together,
Yeah.
right? 7 add negative 2 is 5, right? 7 add negative 2. Right, let me ask you this one then. What would be 3 to the power of 2 multiplied by 3 to the power of negative 7? Would be 3 to the power of negative 5. Which would be? Let's just keep it 3 to the power of 5. Okay? So we might actually be able to show that we've got a fraction now, because if I were to rewrite this in a different way, I could write 3 to the power of 2 is actually 3 times 3. And what are these? That is multiplied by 1 over 3 times 1 over 3 times 1, and so on, yeah? And a 3 multiplied by a 1 over 3 is 1. So they cancel each other out. So that's the thing we've done before about cancelling out. Okay? But you can see the same rules apply. You still just add the two powers, right? Make sense? Ish. So if I ask you one more then, so I would like you to do 2 to the power of 5 multiplied by 2 to the negative 2 multiplied by 2 to the negative 1. Please do it in your book. And the simple answer is
4.
4. 2 to the power of 2, because we just add the powers, and the answer is 4. If I were to write it in a different way, it would be 2 to the power of 5 divided by 2 to the power of 1 times 2 to the power of 2. Sorry, I did it the wrong way around. Does that make sense as well, yeah?
Yeah.
The negatives become a division and a positive. Yeah. Okay? That's negative exponents done. We have, at some point, got to talk about fractional exponents.